Hey, what's up? Welcome to this new video. This one is paper 2-2 of May-June 2021. So in this paper, I'll be doing every question, and I will be focusing more on explaining in detail each and every question, and also providing you guys with the thoughts or the mindset of how to approach every question. So let's move on to, I think, obviously question number 1. So let's see what we have over here. So here we have to use the binomial theorem, expand this one, simplifying each term. So again, you can see here we have, in the list of formula here, we have the binomial theorem. So we have to use this formula right here to expand this. So one by one, obviously by comparison, we have what? We have a plus b, and then we have power n. So this will be your a, and this will be your b. So we just have to expand all the 4 terms. So one by one, you will see that will be what? So first we have to take power 4, 0, we begin with 0 always. Then we have 1 here. Then we have plus exponential 2x. Now here we have 0, this will also be 0. Again, this one will match with this one. So this will be the same. Now 4 minus 0 will be 4. Okay, that's the first term. Now continue plus. We have 4 because the power is 4. Now we choose. Now because it was 0 here, the next one will be 1. Right? And on the inside here we have 1 here, and then plus exponential 2x. Now this and this will match. 4 minus 1 is 3, that will be 3. Move on, plus 4, choose after 1 we have 2, that will be 1 exponential 2x. Here we have 2, that will match with this one, and 4 minus 2 will be 2. Keep going on until we reach 4, right? That will be 3, 1 exponential 2x. That is 3, that will be 3. 4 minus 3 will be 1. And finally, we have 4, choose 4. So here we have to stop. So from 0, start from 0, and we stop until we reach the power here. That will be 1 exponential 2x. This is a 4. It will be 4 here as well, will match. 4 minus 4 will be 0, that will be 0. So now we just have to expand each and every term and simplify as much as we can. For the first one, 4 choose 0, obviously we can check. 4 choose 0, that will be 1. So 1. 1 power something will be 1. Exponential power 0 will be 1 as well. You can check. Anything power 0, that should be 1. Okay, that will be the first term. And then 4 choose 1, that should be 4. But of course, you can check, right? 4. And then that will be 1. That will be exponential 2x. Plus 4 choose 2, check again. That will be 6. So 6. And that will be 1, and that will be exponential. So here we have to do 2 times this power 2, that will be 4x. And the next one, we have 4 choose 3, that will be 4, that will be 1, and that will be exponential. 3 times 2, that will be 6x. And finally this one, 4 choose 4, that should be 1. And then this is obviously a 1, because anything power 0 will be always 1. And this again will be 2x times 4 will be 8x. So simplify. So 1 times 1 times 1 will be 1. 4 times this will be 4 exponential 2x plus 6 exponential 4x plus 4 exponential 6x and plus exponential 8x. So this will be expand, or this term, this expression, into this. So that will be your 2 marks. Again, this is not very hard. As you can see, we're able to proceed step by step of how we do this. That will be part 1 of your question. Now let's move on to part 2 of your question. So on the axis below, as you can see, we have the x-axis and the y-axis given to you. Axis, that's what it means. We have to sketch the graph of this, of y equal to 3. Then we have x minus 3, x minus 1, x plus 2. Stating the intercepts with the coordinates axis. So now let's break it down part by part, or piece by piece, to see what it means, right? So first thing first, here we have to sketch this graph. As you can see, here we have x, x, and x. If you were to expand the whole thing, you will most likely have something in x power 3, right? Now, something we have to know is that if you have something in x power 3, usually your graph may look something like this, or like this. So we only have 2 possible options, like this or like this, because of the x power 3. Now, of course, we all know that x squared, it should be something like this or like this, right? This is your maximum curve, this is your minimum curve. Again, we will go based on these two options. So one by one. Now let's see this line. Stating the intercepts. Now what does this mean? It means that we have to show exactly where the graph cuts the y-axis, but also where it cuts the x-axis. That's what it means. And of course we have to show where the coordinate or the points on the axis. So we have to mark the points where it cuts the axis. So one by one. Let's first begin. So here we have this equation. Let me write this below here. So we have y equal to 3 x minus 3 x minus 1 x plus 2. Right. Now let's see where it cuts my y-axis. So you would say so you have to know this. At y-axis, what happens? We have to know that x will be 0. So this is always true. On the y-axis, x will be 0. Replace a 0 here in this equation. So y will be what? That'll be 3. So 0 minus 3 will be minus 3. 0 minus 1 will be minus 1. 0 plus 2 will be 2. Simplify. You will have 3 times minus 3 times minus 1 times 2. That will be 18. So the point on the y-axis will be 0, 18. That's the first point that we have to show. Now let's move on to the x-axis. Let's see what can we write here. So you would say at the x-axis. Now as you can see here, at the y-axis, x is 0. So at the x-axis, obviously y will be 0. Replace the value of y here by 0. Let's see what happens. 0 minus 3 x minus 1 x plus 2. Now we have to solve for the values of x. Now this equation is already factorized for you, so we can just equate to 0. Again, 3, we can just ignore the 3 because it is only a multiple. We can just pretend, let's say for example, divide by 3 everywhere. This will go away, right? So we only have these remaining. So you will have x minus 3 can be 0, x minus 1 can be 0, x plus 2 can be 0. So x will become 3, x will become 1, and x will become minus 2. Again, these are the x-intercept, x-axis, the points where your curve meets the x-axis. Now let me write the points. That'll be x is 3, y will be 0, x is 1, y will be 0, x is minus 2, y will be 0. So these are the points will be on the x-axis. Now obviously, as you can see here, we have sketch. Sketch means it doesn't need to be exact. It doesn't need to be exactly where it is supposed to be. We just have to provide an idea, an illustration. How is the curve supposed to look like? So let me kind of approximately draw this curve. So the first point here is 0, 18. Let's say 18 should be somewhere over here. Let's mark this as 18. We have to show 18. And all these points, that will be 3, 1, minus 2. So let's say we have 1 here, we have 3 over here, and then we have minus 2 somewhere over here. For example, doesn't need to be exact. That's the whole point. Now we have to kind of sketch this. Now we have to decide, hey, we have two options. Is it going to be like this or like this? So by observation, obviously you can see between those two, the graph goes up, so you will have to be in this shape, right? So something like this. Here you go. Obviously, you'll be drawing this with your pencil, because the goal here is to be as smooth as possible with your graph. Again, you don't need to show the minimum point nor the maximum point. It is just the shape of the graph. You can always continue this and this going on, and you will be using a pencil obviously for this one. Now obviously at the end you have to label this as y equal to your equation, which is 3x minus 3, x minus 1, and x plus 2. Okay, and that will be your question number 2. Now let's move on to question number 3. So here we have to find the value of the constant k. So k is right here, right, and here, for which this equation right here has real roots. Now we have to understand, real roots mean, it can mean 1 root, or it can mean 2 roots. It can be both of those options. Now, usually when we have only 1 root, we would say b squared minus 4ac have to be equal to 0. When we have 2 roots, we would say b squared minus 4ac have to be more than 0. Now, combining these two together, obviously because it can be 1 or 2, we would now deal with b squared minus 4ac is more or equal to 0. Okay, so that's the main idea. Now we have to solve this equation. As you can observe, here we have x squared, x, and here we have a constant. This looks a lot like, I would say, a quadratic equation, right? So we will kind of label this as a, this is as b here, and this is c. Replace back in your equation, that will be what? The value. Replace these back in here, you will have b squared, that will be 36. 6 squared will be 36, minus 4 times a will be 2k, minus 1, times c will be k plus 1, equal to, more equal to 0. So this is the equation we have to be solving. Now let's try to simplify. Let's see what happens. So here we have 36 minus, so 4 here. So 2 times this will be 2k squared. 2 times this will be plus 2k, minus k, and minus 1. Again, you have to know how to expand this thing. It is pretty easy. So if you guys don't know, let me show you guys. Again, this is supposed to be a detailed explanation. So here we have 2k minus 1, k plus 1. So we can just take the first one here, 2k, multiply by the entire thing on the back. And then here we have minus 1, take minus 1, multiply by the entire thing on the back as well. So this is how you can expand this if you want to. So step by step, you will have 2k squared plus 2k, and then here will be minus k minus 1. That will be 2k squared plus k minus 1. So simplify. You will have, of course, here we have to always write this. Minus 4, that will be 2k squared plus k minus 1 had to be more equal to 0. Now something we realize here is we can simplify this equation, because we can see here we have 36, and we know that 36 is actually 9 times 4. And here we have 4, so we can divide by 4 everywhere. So this will become 9, this will become 1, that will be 2k squared plus k minus 1 has to be more equal to 0. Simplify, let's see what happens. So I can, of course, expand this. You will have 9 minus 2k squared minus k plus 1 have to be this, minus 2k squared minus k. 9 plus 1 will be plus 10. Now, example here, I don't like to work with negative values. I can always send everything to the other side, so you will have something like this. Plus k minus 10 have to be less or equal to 0. Again, this is just my preference. I don't like to work with negative values. I can send everything to the other side. We'll have to change the sign here and change the sign for the rest. Okay? Now, once we have this, we can obviously first solve for the critical values of k, which means we take the same equation, we equate that to 0. Now we have to factorize. Let's see if that's possible or not. So let's see. So that will be 2k will be 2k times k, and this will be 3. So 2 times 5. So 2 here, and we have 5 here. Because 10 is 10, here we have 2 times 5 is 10. Now the goal here is to get plus 1k. So here we have plus 5, and then minus 4. So k will be minus 5 over 2, and k will be the value of 2. So these are the critical values of k. It is not your answer. It is just the critical values, the values on the edge of the values we need to find. So let me write this down again. That will be k equal to minus 2.5, and k will be the value of 2. Now we have to use this and use that to find the values, the whole values that are possible for this to be true. So We'll be using the line of this line. This will be the line of 0, of course. And here we will have the first value, which is minus 2.5. And here we have the value of 2. Now, because we have to look at the last one, obviously, because here it is positive plus 2, we know that when we have the coefficient of x squared is positive, the shape of the graph will be a minimum curve. So the same idea here, the shape will be something like this, minimum curve. Right. Now, as you can see, the goal here is to find the values less, which is below the line. So it will be the values right here. Right? Of course, that will be k has to be between minus 2.5 and also 2. But given that it has also equal sign, we have to give it the equal sign. So this will be your answer for the values of k for which this equation has real roots. And that will be your question number 3. Okay, so let's move on to question number 4. The polynomial p of x, we have this right here, where m and n are constants, has a factor of this. Now, whenever you have a factor, it means that if you were to divide this by this, your remainder will be 0. Again, always remember, when you have a factor of something, it usually leads to thinking about the remainder. Remainder will be 0 if you were to divide by this. Now, how would you perform this? For example, you would say, if you have a factor of this, let's equate that factor to 0. Now, what is the value of x? X will be 1 over 3, right? So it means that if my function p of x takes the value of 1 over 3, it will give me 0. So it means that p, taking the value of 1 over 3, it would give me 0. Now replace, let's see what happens. So you have m, 1 over 3 cubed, minus 29, that will be 1 over 3 square, plus 39, 1 over 3, plus n, and have to give me 0 because it is a factor, which means remainder will be 0. Now simplify, let's see what equation we can form with this. That will be m, 1 over 27 minus 29, 1 over 9, plus 13. Let's check. 39 times 1 over 3, it is indeed 13. Good. And then plus n have to be 0. Now simplify as much as we can to see what do we get, right? So here we have m over 27 minus 29 over 9 plus 13 plus n equal to 0. Now usually we want to remove these values on, below here. So how can we do this? We can multiply everyone by 27, right? So we can remove the denominator. So doing this, that will become m. That will become 29 over this times 27. Let's see. That will be 87, so minus 87. Plus 13 times 27, that will be 351. And plus 27n, that will be 0. Simplify. That will give me m plus 27n is equal to what? Minus 87 plus 351. That will be this. Now we have to send this to the other side. That will become minus 264. So this is my first equation that I was able to form with m and n as the unknown values. That's my first equation. Now what are the rest? Here we have, and we have a remainder of 6 when we divide by this. Now when you divide by x minus 1, we equate that to 0. X, the value will be 1. So it means that when p takes in the value of 1, the remainder will be 6. That's what it means. Now we replace back in the main equation. Let's see what happens. It will be m times 1 cubed, so minus 29 times 1 square, plus 39 times 1 plus n have to be 6. Now simplify. That will be m minus 29 plus 39 plus n equal to 6. M plus n, that will be plus 10 minus 6 have to be 0. Let's check. Minus 29 plus 39, that will be indeed 10. So let's simplify. M plus n, that will be what? Plus 10 minus 6, that will be 4, have to be 0. So m can be minus 4 minus n. Again, this is my equation number 2, where I express m as the subject of formula. And why did I do this is because I want to solve this equation to find the values of m and n, right? So let's do this. Replace m by this value. Let's see what happens. You will have m is also equal to minus 4 minus n plus 27n is equal to this. Again, in the question, they did not ask you to find m and n specifically, but again, these are values that we need to find, right? It makes sense because they didn't give you those values. They gave you this information for what? The reason is to find those unknown values. So we have to kind of read between the lines what we need to do first before finding the actual answer here for the question. So let's first find that. That will be what? Here we have 26n, and that will be what? Minus 26, 4 plus 4, that should be minus 260. So n will be minus 10, and m will be minus 4 minus 10. That will be minus 4 plus 10, and that will be the value of 6. So here you go. The values of m is 6, and n will be minus 10. Now obviously we can replace back in the equation. So p of x, that will be m is 6x cubed minus 29x squared plus 39x plus n will be minus 10. This is my equation p of x. Now we have to use that equation. Let's see what we have to show. We have to show that x minus 2 is a factor of this. So pretty easy. There's a few ways we can show this. So one, we can say if this is a factor of the equation, we understand that the remainder have to be 0. That's one way of showing that. So let's do this. Now we take the same thing here, we equate that to 0, which means x have to be the value of 2. Let's check. When p takes in the value of 2, let's see what happens. That will be 6 power 3, 29 to power 2, plus 39, 2, and minus 10. Now if this whole thing becomes 0, it will prove that it is a factor, right? That is one way of doing this question. That will be 8 minus 29, that will be 4 plus times 2, that will be 78. Again, always just use a calculator because you don't want to be making silly mistakes. And I know what I'm talking about because I make a lot of silly mistakes. So make sure you use your calculator. So always be careful, right? Because why not? Even though if you can, you may be very smart, but sometimes you can make some silly mistake that you wish you would avoid just by using your calculator. So let's see what does that give us. 48 minus 116 plus 78 minus 10. And that will be indeed 0. So we have shown as required. Because we have shown the remainder is 0, hence x minus 2 will be a factor of this polynomial. And that will be your question number 4. Now let's move on to question number 5. Here, what do we have? The function f is defined for this domain. Domain is the x values between 0 and 8, 10. Now f of x is given to you by this. Okay, so we have this. Now question, part 1, we have to write down the amplitude of f. So pretty easy. We just have to kind of compare with our initial equation. So usually when you have y equal to a cos x, cos bx plus c, the amplitude will be the value right here. Always the value in front of the cos. By comparing, you will see here we have 1 cos 2 over 3 x plus c. So okay, say plus minus 2. So by comparison, you can see the amplitude here will be 1. So write down should be pretty easy. So amplitude will be the value of 1. Now we have to find the period of f. So to find the period, we use this method. We'll look at the value of b. Comparison, b will be the value over here. So we have to know this to find the period because it is a cos curve. Now for cos and sine, we will be using this formula, which is the period is equal to 360 divided by the value of b, which is 360 divided by 2 over 3. That will be 540. So your period will be 540 as your period. Again, this is only for sine and cos curve. Now, if you had a tan curve, remember, to find the period, that will be 180 divided by that value of b. This is only for tan curve, but this one will be for sine and cos curve. Okay, that will be part 2 of your question. Now for part C, on the axis below, sketch the curve, the graph, sketch again for this one. So again, as always, whenever we're dealing with cos curve or trigonometric curve, let's use a table of values. Let's make our life easier. So one by one, right? So here we have f of x is given to you by minus 2 plus cos 2 over 3x. Now let's input all those values as well. So here we have x can be 0, 90, 180, 270, 360, this 540, almost done, 630, 270, sorry, 720, and 810. Now we just have to replace the value back in the equation. So here we'll be careful. We have to use degrees because it is given to you in degrees. That's the reason why. That'll be minus 2 plus cos. We have 2 over 3 times x will be 0 at first. That will be minus 1. That's the first value. Then it will be 90. That will be minus 1.5. Then it will be 180 minus 2.5. There will be 270. Let's see what happens now. Minus 3. And then we have 360. That'll be minus 2.5. As you can see, the curve are kind of cyclic. It goes up and down, right? And then here we have 450 minus 1.5. I guess we can guess what's going to happen next, but let's go all the way. Why not? That'll be minus 1. And 630 minus 1.5 and 720. Almost done. And 810, here you go. That'll be minus 3. As you can see, minus 1, minus 1.5, minus 2.5, minus 3, minus 1, minus 1.5, minus 2.5, minus 3. So it's always, it kind of repeats itself. It goes up and down, as you can see. That's how we call them cyclic curves. So let me now sketch them. Let's first mark the points that we have on the graph. First is 0, minus 1. That should be right here. Because here we have minus 5. Obviously, that will be minus 1, minus 2, minus 3, minus 4. So that's why. And we have 90 minus 1.5. That should be somewhere over here. Then we have 180 minus 2.5. That's 2.5, somewhere over here. 270, that should be minus 3. That should be right here. And that should be right here, and here you go. And what else? So we have this, and then we have same thing again, repeats itself. Okay, here, and then we have the last one. Here you go. So now just make sure you join all the points by a smooth curve. Of course, use a pencil, because if you do make a mistake, you can always erase that, right? So that will be something like this. Here you go, join that, this and that. Almost done. There you go. Okay, so that will be your curve, and label this as f of x, or y equal to f of x. And that will be your answer for question number 5. Now let's move on to question number 6. So the points A and C are given to you, 5, minus 4, 11, 6, are such that AC is a diagonal of a square. So square, we know a square, all the sides have to be equal. So that's the main thing we know about squares, and also the diagonals are always the same as the sides. That makes sense. Now first thing first, we have to find the length of AC. So pretty easy, just use the formula that we know. So the length of AC will be what? Square root of, so let's do x2 minus x1. That will be 11 minus 5 will be 6. That will be 6 square. Then plus. Then we have 6 minus 4 will be 10 square. 10 and square. That will be what? 6 square plus 10 square. That will be 136. and let's equate that. Sorry, that will be 11.7 correct to 3SF, right units for the length, obviously, of AC. Now next thing, let's move on to B1. We have to find the coordinates of the center E of the square. It is 8 this. Find the value of y. So again, I would say it's best to draw something because you can understand exactly what's happening. So let's say this is my square. A, B, C, and D. This is my diagonals. This is my point E. So I know the point E is given to you by 8y, okay? The point A is given to you by 5 minus 4. The point C is given to you by 11 and 6. So we do understand that E is a center, so obviously it is the midpoint of AC. So how do you find midpoint usually? You will do, so 5 plus 11 divided by 2 and minus 4 plus 6, so y1 plus y2 divided by 2. That will be what? That will be 16 over 2, and that will be 2 over 2. So by comparison, that will be 8 and that will be 1. So that will be 8 and y. So obviously y will be the value of 1. Right? That is the answer for part B. Now for part 2, we have to find the equation of BD. Now to find the equation of BD, we have to understand when we have diagonals of a square, they will be at right angle to each other. So that's something we have to kind of know to solve this kind of question. Now to find the equation of a line, we must have the gradient of BD. But now before you have the gradient of BD, we have to find the gradient of AC, because that's what we can find first, because we have the points A and C already. We can find that, and then we know we can use that to find this. So let's find this first. So that will be what? y2 minus y1, so 6 minus 4 over 11 minus 5. That will be a 10 over the value of 6 divided by 2. That should be the value of 5 over the value of 3. Now this is the gradient of AC. Now from this, the gradient of BD, that will be what? That will be obviously minus 3 over 5, because they are at right angle to each other. Something we have to know, if we have two lines at right angle to each other, we have to understand their gradients. For example, here we know the gradient of BD and the gradient of AC, they are at right angle. If you take this one multiplied by this one, it will be giving you the value of minus 1. So that's something we have to know to solve this question. That is your answer for this part at least. Now we have to use this to find the equation of this one. To find the equation, we need to find the gradient, but also we have to have a passing point. But now we realize, hey, by the way, on this diagram we can see E is clearly a passing point. It is on both lines. So E will be 8, 1. We can use that. That will be x value, y value. So y minus 1 over x minus 8. Again, this is just the method that I use to find the equation of a line. If you have some other method, you can always use your own method, right? Cross multiply, you will have 5y minus 5 minus 3x plus 24. Now we have 5y, that will be minus 3x plus 24 plus 5, that should be plus 29. So this is my equation of BD. Now again, you can always simplify, make y become subject. It is up to you. You don't need to. It is up to you. Okay. Now let's move on to question part 3. Given that the x value of B is less than the x value of D, as you can see here, it is exactly as drawn here. The value of x. What is x value? Usually when you look at your x-axis, we are looking at the values on this x-axis. As you go inside, as you go on this way, the value will be more. If you go to this side, the value will be less. As you can see, B has to happen before D. So D is in a good position here, and B have to be in this position here. So that's the main idea here that we have about this question. Now we have to write EB and ED as column vectors. Here I was going to draw this, by the way, so let me move on to question part 3. So in this case, usually in exam situation, honestly, I would not waste too much time thinking about this question. It's only 2 marks, right? So usually I would just draw it, to be honest with you guys. It's just way simpler than thinking about this question the whole time. So for example, we know that for part 3, we know the point A is given to you by 5 minus 4. The point C is 11, 6. And point B, we don't know. And point D, we don't know, right? Now, we know the point E, which is the center, which is 8, 1. Obviously, there's many ways of doing this question. One of the ways is using the gradient that we had previously found, which was the gradient of BD was found to be minus 3 over 5. So we could have used this to also find the value of, I think the question was asking for EB and ED. Again, if I was you guys, I know it's only 2 marks because this question is not very common. It is kind of tricky. I would have just drawn this because it would be just such a, I would say, waste of time just to think too much about that question. So let me just try it. Let's see what happens. So we have a vertical axis. So these are the values. There you go. So I think in this case I'm giving you guys a realistic way of how I would do this, because usually in exam period you cannot stress and you just don't want to think too much on how you can solve a question. You will waste a lot of time. So in those cases, honestly, I just resort to the easiest solution. I was like, hey, let's draw this. I know how a square looks like, so I'm sure I can draw a square, right? So we have a few points here. Let's see what are the values we need to have. So let's try to mark a few values over here. We have to have at least till 11. Okay, 11 is the max on the x value. So let's see. Here we have minus 4, so we have to have minus 4 at least for this one. Okay, so here we have, let's say we have minus 5. That'll be minus 4, minus 3, minus 2, minus 1, and 0. From here we can continue. Obviously, this is not the smartest way of doing the question. I'm sure there's easier way as well to do it, but usually it's because it's not very common. That's why I will opt for the most trivial way, I would say. So here we have 1, 2, so 4, 6, 8, 9, and then we have, sorry, not 9, 10, and then 12, and so on. X. Here we have 2, 4, 6, 8, 10, 12, 14. Okay, so let's try and see what are the values we can have through drawing. Again, this is not the best solution, but hey, it can help you to save some time and some headache, so why not? So the first point we have is 5 minus 4, right? That's the point A. So 5 minus 4, so 5 is right here. Minus 4 should be somewhere over here. Right, that's the point A. And the point C is 11, 6, so 11 is right here. 6, that should be somewhere right here. Okay, so these are the 2 points that we know. Now, and the point E is the point 8, 1, so 8, 1 will be something right here, right? So let's try to connect them first. So we know we have a diagonal. These let me use a different color here. That'll be the diagonal. Right. Now we also understand that the other side will have to be of the same length, also at 90 degrees on the, because we know for a square the diagonals, they are at 90 degrees to each other, as we have seen before, right? So we can kind of draw a line here at 90 degrees to each other. So again, you can approximate this, it is up to you, or we can try our best to make this seem as best as we can as 90 degrees. So let's kind of continue this. Okay, here you go. Now we have this. Okay, now what else can we do? So we can kind of play with this. It seems to be in this direction, so there has to be at least 45 degrees over here. Approximately that should be 90 as well. So let's see, how can we open this up? Again, it doesn't need to be exact value, so it has to be something that we can actually kind of estimate, right? So from what I can see, it should be something like this, right? And there should be something like this over here, and should be something like this over here. There you go. Now you can see you tried your best to kind of draw this, and obviously the points we will have will be this point and this point here. Obviously we know that the b value of x have to be before, so this have to be b, this is a, c, and d. So we had only two choices. We could have b here or b over here, because b, the value of so the x value of b have to be before that of d, so we know that's have to be b over here, and this will have to be so b and d over here. So approximately you can see here, obviously they will give you points, they will give you exact points, if that makes sense, right? They will not give you approximate points for this question. So as we can see, they have to be, the best estimation have to be 3 and then 4, and this one have to be what, 13 and then best estimation minus 2. Okay, so now we know these points, we can find the directions. So we know this is E given to you by 8, 1. So first direction, EB is equal to OB minus OE. So OB will be the point B, 3, 4 minus OE, that will be 8, 1. That will be minus 5, 3. And ED, that will be OD minus OE. 13 minus 2, and then OE will be the value of 8, 1. That will be 13 minus 8, that should be 5, and then that should be minus 3. So as you can see, we're able to find the values respectively. So again, I don't think this is the smartest possible option, but sometimes in an exam, you don't want to be wasting too much of your time. You just go with the most trivial option you have. You can always solve this question in this way. Now there's other ways we can solve this question. We can use the gradient, right? Or we can use the vector method, right? We can use, so from E to go to C, we can first find that, and we understand that we can just rotate to go to B, so, and then keep going on to A and to D. So that will be the other option as well of doing this question. That will be for question number 6. Okay, so let's move on to question number 7. So here we have DAB is a sector of a circle, center A. As you can see here, we have A as a center, and here we have a sector of a circle, DAB. This is the sector of a circle. Again, let me show you guys. This is the sector of a circle. Okay, that will be A, B, and D. Now, the radius here is 18. So this is 18. This also will have to be 18. Radius are equal in size. Now the line CD and CB are tangents to the circle. Now, these two are tangents. So by being tangents to the circle, we understand that these two have to be the same. Now the angle is given to you by 7 pi over 9 radians. So this whole thing will be 7 pi over 9. So by conclusion, if this is same, so same too, this will have to be same as well. These two, we can break it down into two parts. Divide by 2, that should be 7 pi over 18 for this one and this one. Now let's move on. So part A, we have to find the perimeter of the shaded region. So as usual, we can always break it down into two pieces and then look at one and then multiply by 2 because they're the same to find the perimeter. Now, one by one, how would you find the perimeter of this region? So by observation, I mean in this case we don't have to, I guess for area we'll do this way, but this one step by step. To find the perimeter by observation, you would say, we know that perimeter is a distance around the object, around the shape or the area. That will be this one, this and this. So we understand that will be BC plus CD plus BD. That will be the perimeter. Now what can we find? We can find this first, pretty easy. BD is the arc length. Now we understand arc length is given to you by the formula r theta. R is 18, theta is just the angle, 7 pi over 9. Now simplify, this will go away. That'll be 14 pi. So this will be 14 pi. Now let's move on. How would you find this side and this side? So again, you can see these two sides are the same. So we can just first find one of them and then just multiply by 2 or add the same again. So no big deal. Let's first find the one of them. So let's take this out. We have this shape. This is 90 obviously because it is a tangent to the circle. Now if you have a tangent to a circle, at the point where it meets the circle, if you join that point to the radius, to the center, sorry, we have to understand this have to be 90. Okay, so this is something we have to know before solving this question. As you can see here, it is given to you as well over here as 90. So same thing, it will have to be 90. This is 18, and we know this angle. Let's call this theta for now. And we're trying to find this length. So how would you find this length? So let's see. We can use SOHCAHTOA because it is a right angle triangle. So let's use that. So here we have the A side. SOHCAHTOA, right? Now how do you know it's the A side? Because it is between the angle and right angle, we will call this the A side. This is A and A. We're trying to find this side. This is the O side. It is always going to be right behind this one will be the O side. So O will be O and O. As you can see, this one has the most marked alphabets. We will use this one. We can use tan of the angle alpha is equal to O over A. So that will be O is, we don't know, we're trying to find O side. Over A is 18. Again, that is tan alpha. Alpha is the angle over here, 7 pi over 18. So to find the value of O, that will be 18 tan of 7 pi over 18. So let's use this angle in radians. Why do we use radians? Because the values given here are radians. And sometimes circular measure questions, it is best you use radians because you can use these formulas. That's the main reason why. So we have 18 tan of 7 pi over 18. That will be 49.455. Now again, this is just one of the sides, which is this one. That is 49.455. This is again 49.455. Now let's add everything together. So we have to add this one, add this and add this. So one by one. Answer was this one times 2 and plus 14 pi. That will be 142.89. But obviously correct to 3 SF, that will be what? 143.0 centimeters. That will be your perimeter of this area, of this region. Now let's move on to part B. Well, we have to find the area of the region. So how would you find the area of the region? So in this case, we will again break this down into two pieces. Let's first find the area of this one, and then just multiply by 2 to get the other one as well, right? So to find the area of this one, we can first find the area of the whole thing, and then minus this one to get this one as a remainder. So of the whole thing here, obviously, as you can see, it is a right angle triangle. So how would you find the area of a triangle, of a right angle triangle usually? They will say it is half times base, which is DC 49,455, and times height is 18. Here you go. Half times 49.455 times 18, that will be, let me write this down first. So area of triangle is 445.095. Now we need to minus this area that we don't need, so we can only have the one that we need. So this one is area of sector. And how do you find area of sector? Pretty easy. We just use our formula, which is half r square is 18 square, theta is the angle of the sector. Again, this is the formula we can use when we use the angle in radians. Again, area of sector is equal to half r square theta. This is the formula we can use for angle in radians to find the area of sector. Now simplify, that will be what? Half times 18 square times 7 pi over 18. That will be 197.92. Simplify, 445.095 minus 197.92. That will be the value here. Right? But now we do understand this is only part of the area we're trying to find. We're trying to find the whole thing, so we just multiply by 2, right? So this multiplied by 2, that will be 494.35. So eventually you can write 3SF, that will be just 494.0 centimeters square for the area. And that will be your question number 7. Now let's move on to question number 8. So here we have a particle moves in a straight line so that t seconds after passing through a point O, its v value, its velocity, is given to you by this. Okay, so now we are given the equation for v, but we have to know at the back of our mind that usually this question will be involving acceleration, but also displacement, right? So one by one. Part A. We have to find the distance between the particles' 2 positions of rest. So one by one. So how would you find that? So first we have to find what is the time at which they were at rest. Now we know the particle is at rest when v has to be 0. So let's equate that to 0. That will be 3t squared minus 30t plus 72 is 0. Now we can divide everyone by the value of 3. That will be t squared minus 10 plus what? 72 divided by 3, that will be 24, plus 24 have to be 0. Now we can simplify, obviously. That will be what? Factorization, t times t. 24 is what? It is 6 times 4. To get minus 10, we have to have minus 6 minus 4. So your answer will be t will be 6 and t will be 4. So you do realize that your particle, it is at rest at those 2 times. Right. So now the question is, we have to find the distance traveled between these 2. So right now we only have the equation for velocity. We don't have the equation for distance travel or displacement. So we have to find that first. So to find the equation for displacement, that will be, we have to integrate the value of v respect to t. That will be integration of 3t squared minus 30t plus 72 respect to dt. That will be t cubed minus 15t squared plus 72t plus the constant c. Now obviously we have to find this value. Pretty easy. We understand that at first, when time is 0, obviously we haven't moved yet, the displacement will be also 0. That's something we have to know. It's logic, right? Because before we start moving, we will always be at the initial position. We will not move. That's why it's 0. Now replace back in your equation, you will have 0. This will be 0 minus 0 plus c. So c will be 0. So now we have this one. That will be s is equal to t cubed minus 15 t squared plus 72t. Now we can find out one by one. What is the value of s when t is equal to 4? When it first comes to rest, that will be 4 cubed minus 15 times 4 square plus 72 times 4. That will be 112. Let's check one more time. So 4 cubed minus 15 times 16, and then we have plus 72 times 4. There you go. Now what else? We have this one, time at 6. That'll be 6 power 3 minus 15 times 9 plus 72 times 3. That'll be 297. Okay, so here you go. We have those values. Now we can definitely find the difference. So the distance between those particles, we can just take this value minus that value. That will be what? 297 minus 112. That should be 185 meters. That will be the distance between those two particles. Okay, so there we have it for now. Now for part B, let's see what else we have to find. So we have to find the acceleration of the particle at time equal to 2. So pretty easy. To find the acceleration, we understand that we have to differentiate the value of v with respect to time. So we know v was given to you by 3t squared minus 30t plus 72. One by one, so that will be, first multiply by this, that will be 2 times 3 will be 6, then we have to minus 1 to the power, become this, and then we have to, this become this. So we realize that, hey, we have acceleration is equal to 60 minus 30. Now we just replace. What is the value of a when time equal to 2? That will be 6 times 2 minus 30. That will be 12 minus 30 minus 18 meters per second square for the acceleration. Now if the question was asking you for deceleration, it will be provided as a positive value. Again, acceleration will be negative right here. And that will be your question number 8. Now let's move on to question number 9. So here what do we have to do? We have to solve the simultaneous equation, so meaning we have to find the value of x and y. So one by one, this one is kind of complicated. Let's make this one become subject. So here we have what? We have xy is equal to minus 4. Now because here we have xy, we can replace this one. Here you will have 4x squared plus 3. xy is given to you by minus 4, right? And plus y squared is equal to 8. Now of course we have to keep going on. Y will be the value of this over x. Again, you can always make x become subject or y become subject. It is up to you. It is your preference, right? That will be what? 4x squared minus 12 plus y squared. So y is this? Y squared will be 16 over x squared, have to be the value of 8. So now we have to simplify. Let's send this one over here. You will have 4x squared plus 16 over x squared. So send this over here, become 8 plus 12, that will be 20. Now something is kind of off here because we have x squared at the bottom. So we have to remove this one. If we want to eliminate this one, we have to multiply everyone by x squared. You will have x power 4 plus 16 equal to 20x squared. Now send everyone to one side, you will have what? 4x power 4 minus 20 x squared plus 16 have to be 0. Now we do realize we can always simplify this equation because here we have 4, 20, 16. They are all multiples of 4, so let's divide by 4 everywhere. That will be x power 4 minus 5x power 2 plus 4 has to be 0. Now we can factorize. That will be x squared, right? Because if you do realize this, what is this, right? So x power 4 is simply x squared square. If you were to replace this by something else, let's say you would say let u equal to x squared, you would have u squared minus 5u plus 4 has to be 0. This is a regular quadratic equation. Same logic here. We just factorize and try to solve for the values of x. Now what is 4? 4 is 4 times 1. That'll be 4 here, 1 here. To get the value of minus 5, we have to have minus 1, minus 4. So x squared minus 1 will be 0. X squared minus 4 will be 0. X squared have to be 1, so x have to be plus minus 1. X squared have to be 4, so x will have to be plus minus 2. Now replace back to your equation. We know y is given to you by minus 4 over x. Now, when x is equal to plus 1, y will be the value of what? Minus 4 divided by plus 1 will be minus 4. When x is given to you by the value of minus 1, y will become the value of 4. When x is given to you by the value of plus 2, y will be minus 2. X is given to you the value of minus 2, y will become the value of 2. So these are your answers for this equation. That will be your question number 9. Now let's move on to question number 10. So here we have to find this integral. So one by one, what can we do first? We can first expand this. Let's simplify. You will have this one. Let's bring this inside. You will have 3x plus 3 dx. Now if you want to break this down, you can also do that as well. It is up to you. For example, we can use the laws of indices. That will be 3x multiplied by exponential power 3. Now we can just take this outside. That will be exponential 3 integration of this 1, and that will be dx. Right. Now one by one, we can integrate this. That will become 3x divided by 3. Of course, plus c for your constant of integration. Now if you want, you can bring this in. It is up to you. That will be the same thing as saying this plus 3 over 3 and plus c for the constant of integration. Okay, that will be your question part A. Now let's move on. For part B, differentiate with respect to x, this one. As you can see, this is a product, x times this one. So because of that, we have to use the product rule. So dy by dx will be what? So first thing, we'll leave the first one as it is. Then differentiate this one, that will be cos 4x. That will be times 4 plus. Then leave the second one as it is. Then times d by dx of this one, that will be just 1. That will be 4x cos 4x plus sine 4x. Now let's move on to part 2. Hence, now whenever you see hence, it means we have to use part 1 to solve this question. So we have to solve this. Now where have we seen this? We have seen this exactly right here. So something we have to understand here is that integration is a reverse process of differentiation. So what does that mean? It means that when we differentiate this one, we get this one. But if you were to integrate this one, right, this one at the end, you're supposed to get back the original expression. That's the main idea. So now we have to solve for only this one. So make this one become the subject. That will become this 4x cos 4x dx. That will be x sine 4x. We have to send this one over here. That will be minus integration of sine 4x dx. Simplify. 4x and now a minus, obviously that will be what? That will be what? So if you were to integrate sine, we know integration of sine is what? That will be minus, sorry, actually plus cos, because when we so it is minus actually, because if you think about this, let's say for example I forgot. How do I remember this? So pretty easy, because we know when we differentiate sin x, you will get cos. When you differentiate cos x, that will be minus sine. So when you integrate sin x, you will get minus cos. So you can see this is how we can use that to recall this one. So you have the same idea here. When you have minus sine 4x, that will be minus cos 4x divided by 4. Now just replace all the values in. Let's see what happens. You will have what? X sine 4x plus cos 4x over the value of 4, and the limits are given to you by pi over 3 and pi over 4. So one by one, this one replace first. You will have what? Pi over 3 sine 4 pi over 3 plus 1 over 4 cos 4 pi over 3, that's the first one. Then minus this one, pi over 4 sine pi plus cos pi over 4. Here we have to use radians obviously. So what is this one? Sine of pi will be 0. Cos of pi will be minus 1. That will be minus 1 over 4. Now this one, what do we have here? So sine of 4 pi over 3, that will be this value. So it is simply minus root 3 over 2. Again, this is the exact value we have to kind of know. Or you can use I think they have different calculators now. You can use that to find the exact value for this kind of expression. That is pi over 3. 1 over 4, and here we have cos of 4 pi over 3. This one, that will be this one. That will be minus 0.5. So simplify. That will give you what? So here we have minus this pi over 6. Here we have minus 0.5 over 4. Minus minus become plus 1 over 4. So minus 0.5 over 4 plus 1 over 4, that will give you 1 over 8. So you will have 1 over 8 minus pi root 3 over 6. And this is shown as required. So here, this is only trick here. If you guys don't know, this will give you an exact value. So what is 4 pi over 3? 4 times pi will be this, divided by 3 is this. So simply sine of 240 will give you this over 2. So this is something we have to know to be able to show this is exactly this. Again, it depends on the calculator you use. Sometimes I know now you have more modern calculator that will give you exact values, and that will be your question number 10. So now let's move on to question number 11. So in this question, all the length are in centimeters. Right. Now, the volume and the surface area of a sphere. Sphere is kind of a ball, the whole thing, right? Is given to you by this formula. This is the volume, and the surface area is given to you by this, respectively. But now, by observation, we have to kind of realize in this diagram, we actually have a hemisphere. Hemisphere is half a sphere, so obviously the volume will be half of this, so volume will be divided by 2, that will be 2 over 3 pi r cube, and the surface area, the curved surface area, will become 2 pi r square for the hemisphere, half a sphere. Then let's move on. So the diagram shows a solid object made from a hemisphere of radius x, as you can see right here, and a cylinder of also radius x, okay, of 2 p's. Now, what else do we know? We know the volume of the object is this. So first question is, how would you find the volume of this object? So logically, you know that this object is made up of 2 p's, hemisphere and cylinder. Let's call this number 1 and this number 2. So volume will be volume of number 1 plus volume of number 2, obviously, logically. Now one by one. So how would you find volume of number 1? As we can see here, the volume of a sphere is this one, hemisphere will be this one. So we use this formula right here. That will be 2 over 3 pi r cube. Now r is radius, here we have radius as x, that will be x cube. Plus, now volume of 2, which is this one, that will be what? A cylinder. So this one we have to know. The volume of cylinder is given to you by pi r square will be x square, h, height will be y, right? The height is y. So let me make a note right here. The volume of cylinder will be pi r square h, something we have to know for this question. Now let's simplify. So we have this, we know the volume is given to you by 500, right? You can see the volume is 500. Now for part 1, we have to find an expression for y in terms of x. So make y become the subject of formula. So here we have y. We have to make this become subject. So one by one, let's first send this one over here. You will have y is equal to 500 minus 2 over 3 pi x cube. And then divide, obviously. by pi x squared, right? So one by one, first you send this over here, then divide by this to make y become subject. Now obviously you can simplify if you want to. You will have something like this. That will be 500 over pi x squared, and this will go away. That will become 2 over 3, and that will be, pi will be gone, and that will be just x. Right, because this is x squared, here we have x cubed, so only x will be remaining for this one. Now that will be y in terms of x. Again, you can leave your answer as this as well. There should be no problem. Now let's move on. So here we have this first part, and show that the surface area S of the object given to you is given by this one. So now again, by observation, how would you find the surface area of this object? So pretty easy. It will be the surface area of this one, of the hemisphere, curved surface area of the cylinder, and the base surface. So we have three things to find. Number one, this one. Number two, this one. And number three, this one. So three things. So one by one. So how would you find the curved surface area of this hemisphere? As you can see, the surface area of the sphere is this one. Hemisphere will be half. So number one will be 2 pi x squared. Now the curved surface area, so pretty easy as well. We have to know this formula, which is what? 2 pi r is x, h is y. So this is the formula. So let me write this down. The formula for the curved surface area of a cylinder is 2 pi rh. So we have to know these two for those questions. And finally, for the base area, that will be S of 3, that is area of a circle radius x. That will be pi r squared, that will be x squared. Okay, so we have to add all three. So the total surface area has to be S1 plus x2 plus x3. Now simplify, that will be this plus this, that will be 3 pi plus 2 pi x times y. As you know, y is this one. We can just replace. We can have 500 minus 2 over 3 pi x cubed over the value of pi x squared. Simplify. This and this will cancel out, and this will cancel out. So you have something like this, and that will give you 3 pi x squared plus 2 over x. That will be 500 minus 2 over 3 pi x cubed. That will be 3 pi x squared plus 1000 over pi, and then minus 4 over 3, and this will cancel out. That will be x cubed. Now we have to kind of simplify and see what can be done here, because we have to eventually show that this is the same thing as this. So what is it missing over here? Let's check. This is fine, so we just have to simplify this one. So let me check. Something might be missing over here, because this is supposed to combine with this one. Oh, I see. So mistake over here. This is supposed to be x, not pi. So this will be, pi will be here, and that will be square. Okay, so again, don't make silly mistakes like this. Just be careful, right? So this is this, and this will give you this. Now we can combine. So that will be this part minus this. Let's see what happens. So we have 3 pi x squared minus 4 over 3 pi x squared, and then plus 1000 over x. So 3 minus this, that will be 1/2 pi x squared plus 1000 over x. The same thing as 1 times 3 is 3 plus 2 is 5, so 5 over 3 pi x squared plus 1000 over x. Okay, and that is shown as required for part A of your question. Now let's move on to part B. So given x can vary and s has a minimum value, so we know the nature of the value already, we have to find the value of x for which s is minimum. So we know that when s is minimum, ds by dx have to be 0. So we know s was found to be 5/3 pi x squared plus 1000 x power minus 1, right? Because when you write 1000 over x, it's the same thing as 1000 times x power minus 1. Let's just send this up, right? Just to help us out for the differentiation process. Here, so we have to find ds by dx. That will be 5/3 this, it is just a constant, multiply by the power, and then minus 1, that will be x. And here, same thing, multiply by the power, that will be minus 1000, then minus 1 to the power. That will become 10 3 pi x minus 1000 over x squared. Now obviously we have to equate the whole thing to 0. Let's see what happens. So here we have to step by step try to solve this. So we just have to find the value of x, right? So we have to solve for the value of x. So first thing first, what I can do is I can send this one over here. I will have 10/3 pi x equal to 1000 over x squared. Now I can of course divide by 10 on both sides. This will go away and this will go away. You will have pi/3 x, and that will be 100 over x squared. I can cross multiply, right? This will go here, that will be pi x cubed is equal to 100 times 3. And finally x cubed will be 300 over pi, so x will be cubic root of 300 over pi. So step by step, it's trying to make x become the subject of this formula. So 300 divided by pi, cubic root of this, that will give you 4.57, correct to 3SF. That will be the value of x when s is a minimum. Now let's move on to question number 12. So in this question we do not use a calculator. So what it really means is you can actually use one because no one is watching you. Obviously you just have to show all the steps of your work, right? Now let's move on. So here we have a shape. As you can see, we have a curve right here and a straight line. Okay, now we have this region, so obviously we know we will be finding this area of this region in this question. But let's see one by one. What do we have here? So the diagram shows part of the curve y and part of the line. So we have line and curve, and they meet at this, and this point. So we kind of know we have to find these points already. So let's do that. So how would you find the point A? As you can see, the point A is the point of intersection of the curve and the y-axis. So pretty easy. You know at the y-axis, what do we know? The value of x have to be 0. So replace y will be 1 over 2 times 0 is 0 plus 1. That will be just 1. So the A is a point 0, 1. Now we can find the point B. Obviously now B is on the x-axis. So you would say on the x-axis, what do we know? The value of y have to be 0. Replace in this one, you will have 5 times 0 is equal to x minus 1. That will be 0. X minus 1, x will be the value of 1. So the point B, 1, 0. And here we have to find the point C. How would you find that? So also pretty easy. It is a point of intersection between the curve and the straight line. So here we have y as subject already. Replace in this one, you will have 5 times y, 1 over 2x plus 1 is equal to x minus 1. Now we can obviously cross multiply to see what happens. That will be 5 over here. That will be x minus 1 times 2x plus 1. 5, and that will be 2x squared plus x minus 2x minus 1. That will be 5 is equal to 2x squared minus x minus 1. Send everything to one side, you will have 2x squared minus x minus 1 minus 5 will be minus 6 is equal to 0. Now obviously we can try to factorize this, so that will be 2 brackets. Here we have 2x times x. Here we have 6. 6 is 3 times 2, so let's put 2 here and 3 here. Why? Because here we have minus 1, right? So minus 1 will be minus 4 plus 3 to get that value. So x will be minus 3 over 2. X will be the value of 2. Again, if you guys don't know how to factorize, just use your formula. You can just solve that to find the values of x. Now obviously by observation and elimination, you can see the value of x here obviously have to be a positive 1, so this cannot be your value. So x will be the value of 2, so find the corresponding value of y. Replace back in your main equation, that will be 1 over 2 times 2 is 4 plus 1 is 5. So the point C will be 2 and then 0 point. So 1 divided by 5, 0.2. If you want, you can write that, up to you. Now let's move on. So find the point A and B, done already. Verify x is this, done already. So as you can see, we're able to show that the x value here is indeed 2. Okay, so you can do this in this way, or you can just replace that value back in your equation to see if they meet at the same value. So what do I mean is, if you want to use the other option, is you can just let x be this value, replace the value of x in this line, and replace the value of x in this curve. You should have the same y value. So by having the same y value at the end, it proves that it is actually right. I hope that makes sense, right? That is the other way of doing that question. The last one, we have to find the exact area of this region. So one by one, how would you find that? So by observation, we have something right here. We can definitely draw this line. So we know this is the point 2, right? So how would you find the area of that region? So by observation, you can see, hey, we can actually find the area of the whole thing and then minus this one to get the remaining, right? This is a straight line, this is a vertical line, this is the point 1, this is 90, right? This is vertical. So this is a area of a triangle. That will be half times base. Base is 1 times height. Height will be 0.2. That will be what? 0.1 units square of the area of triangle that we don't need. Now we have to find the area of the whole thing. So as you can see, it will be area under graph between this and this. These are the limits. That will be limits of 2, 0. And the curve is given to you by 1 over 2x plus 1 dx. Pretty easy. That will be ln of the value here, 2x plus 1, then divide by 2. And limits we have is 2, 0. Again, something we have to know by now is how do you integrate 1 over x, right? That will be ln of x. So ln and the value at the bottom. How would you integrate 1 over 2x ln the value at the bottom, and then divide by d by dx of this value. So d by dx of this will be 2. So this is how we do the same thing. 1 over this, so first ln of this, and then divide by d by dx of this will be 2. Again, it is only possible when this is linear at the bottom. So let's solve. Let's see, what do we have. So we have, let's take this one out. You have half outside. Inside you have 2. You have ln of 5 minus ln of 1. So what is ln of 1? That will be 0. So the 0 right here. So let's simplify. That will be half ln of 5 for the area of this whole thing, right? Now obviously we have to minus the area of a triangle. So you will have half ln of 5 minus 0.1 for the exact value of the area. Units square for the area. That is question number 12. Now let's move on to question number 13. So the functions f and g are defined for x more than 0. X is a positive value. Now, as you can see, we have these two. So we have to find this one first. So pretty easy. We just have to write f and take in the value of g of x, for example. That will give you f. That will be 2. Where we have x, we take in the value of g of x square minus 1 over 3 g of x. Now what is this value right here? Let's replace. You have 2. Now what is g of x squared? That will be 1 over x squared minus 1 over the value of 3, 1 over x. That will be 2 over x squared minus 1 over the value of 3 over x. Now we have to simplify, obviously. Let's simplify this one. So here we have 2 over this. Now obviously this is what is 1. 1 is also x squared over x squared. That will be 2 minus x squared over x squared as a single fraction. Now of course we can simplify the whole thing now. For example, when you have, we have a over b divided by c over d. We can rewrite this as a over b. We change divide to multiply and flip this upside down. Here you go. You have this. So same idea here. That will be, this will become a over b, which is this one, 2 minus x squared over x squared multiply by, to flip this, that will be x over 3. This and this will go away. You will have 2 minus x squared over 3x. And that is your answer for part A. Simplify, this is the expression we can give them. Okay, that will be part A. Now let's move on to part B. Given that f inverse exists, write down the range of f inverse. So what is f? F inverse, f of x is given to you by this. So what is the range of f inverse? So we have to know something here is, the range of f inverse is equal to the domain of f. So, right? But now we know the domain of f already. X is, so domain is actually x value, so x is more than 0. Domain is x is more than 0. Hence, to write the range, we know this is more than 0 as well. But to write the range, we use y. We can use, sorry, we have f inverse here. We have to write f inverse is more than 0. So here you go. So we have this as your range. So f inverse is more than 0. Okay. So we can use this thing to find that value over here. Again, it should be easy. It is only 1 mark, right? And the last one is we have to show f inverse is equal to something like this. So one by one, how would you find this? So step number 1 is let y equal to f inverse, which is 2x squared minus 1 over 3x. Now we can cross multiply. You will have 3xy. That will be 2x squared minus 1. Right. Then what else? We have to try to simplify it. Let's try to send everything to one side. You will have 2x squared minus 3xy minus 1 equal to 0. Now let's try to rearrange and see what's happening. Because here, the main goal is to make x become subject, right? So right now we have 2x squared minus 3y, x minus 1 is 0. Now by observation you can see, hey, by the way, here we have x squared, x, and a constant. It looks a lot like a quadratic equation. So we can use our formula to solve this. So a is 2, b is minus 3y, c will be minus 1. So x is equal to minus b, which is 3y, plus minus, we have b squared, that will be 9y squared, minus 4 times a times c, and divide by 2a, that will be 2 times a, that should be 4. That will be 3y plus minus, that will be 9y squared. So here we have minus 4 times 2 will be minus 8 times 1 will be plus 8. And divide by 4. So finally, obviously we have to change the y to x. So f inverse of x, that will be 3x plus minus 9x squared plus 8 over the value of 4. So now obviously you will just drop the minus sign, you will take only the positive value. That will be 3x plus. Again, you may ask me, how do I know? Well, in this case, it's pretty easy because you can see the question has only plus here, so that's why you can just put plus in this case. So that will be your question number 13, and that will be a function question. Again, I hope that was somewhat helpful. As always, thank you for watching. I will see you soon.